Hello everyone. Welcome to CSE Core Concepts. In this video, I am going to discuss about the introduction of stacks. So to understand stacks, first of all, let me tell you that it is a linear data structures. So let us look at some real life examples to understand how the stack operation works. So in real life, we stack clothes, that is we keep clothes one up on the top of other, stack of trays, or you can say stack of books. So basically in stacks what we do is that we add and remove any element from the one side, that is from top of the stack. So it follows a first in last out order. So let us understand how we are going to use stacks using our elements. Say for example, I have 5 elements A, B, C, D and E, and I have a stack and I want to insert these elements inside the stack. So the first element which will be inserted in the stack is A, then comes your B. So B came later, that is after A, but still B is on the top of A because insertion is only done from top of the stack. Similarly, then comes our C, D and E, and this operation of inserting the elements inside the stack is called as push operation. Now E is on the top of the stack, and so when I want to remove the elements from the stack, the first element which I will remove is E, then is D, B, A, C, B and A. And the operation which will allow me, which is used to remove the elements from the stack is called as pop operation. So they can be used in the following ways using a linear array. Okay, you can use a linear array, you can arrange the elements of the stack, and just you can make a restriction that the elements can be removed only from one side of the array, which is your top. But before you can insert any new element in the stack, or before you extract any element from the stack, you have to check for two conditions. So before pushing any element in the stack, you have to check for the overflow condition. That is, there is at least one space in the stack for the element to be inserted. If the stack is already full, then the element cannot be inserted. Similarly, when you want to remove any element from the stack, you have to check that there is at least one element in the stack to be removed. You cannot remove from an empty stack. So that is your underflow condition. Let us understand why do we require stack using arrays here in this case. That is in order to solve the arithmetic expression. So before understanding that, let us understand a mathematical expression given as a plus b into d divided by j plus c. Now, you can see here that this expression involves certain operators, that is plus, multiplication, division, addition. These are the operators, and a, b, d, j and c are the operands. Now, when you want to solve such type of complex mathematical functions or expressions, what happens? You have so many types of operators. So to solve this problem, it requires a clear understanding to know the order of operations to be solved. So many of you must be knowing the precedence, operator precedence. Here again I am going to discuss it. That is, the highest precedence is of the exponential function. Then comes your multiplication and division, and thereafter addition and subtraction. So let us understand this with the example. So I have been given an expression to evaluate, that is 2 to the power cube plus 5 multiplied by 2 to the power 2 minus 12 divided by 6. Now this expression involves exponential function, addition, subtraction, multiplication and division. So this expression is in the form of infix expression. So by infix I mean when my operator is between the two operands, it is called as an infix expression. So you can see here, first I am going to solve the exponential function, that is 2 to the power cube and 2 to the power 2. So by solving these two, my expression takes the form of 8 plus 5 into 4 minus 12 divided by 6. Thereafter, I am going to solve the multiplication and the division operation, and so as to obtain 8 plus 20 minus 2, and then addition and subtraction will give me a result called 26. Now what I can make you understand from this solving of the expression is that for evaluating this, I had to traverse the whole expression 3 times. So, because for in the first traversal, I have solved the exponential function, then I solved the multiplication and division, and thereafter I solved addition and subtraction. Okay, so based on the precedence of the operations. Now, if you have a more complex query, then the number of traversal always increases, right? So each traversal takes time, and the processor time for executing one query increases. Hence, we want to reduce this time. So how to do that? So generally, any evaluation of an arithmetic expression does not take place in the infix form. Rather, it is converted into either a prefix notation or a postfix notation. So by prefix notation, what I mean is that the operator is before the operands. That is, if I have an expression a plus b, then plus ab is the prefix expression, and the postfix expression is ab plus. Prefix and postfix expressions are also referred as Polish notations and reverse Polish notations, respectively. So, with the use of this type of prefix and postfix expressions, the need for repeated scanning or traversal of the infix expression in order to obtain its value is eliminated. So, the query gets solved or the equation gets solved faster. So in my upcoming series in Stack, you will find out the next will be about how to convert an expression from infix to postfix and infix to prefix, and then evaluating the arithmetic expression in the prefix or the postfix form. So for more such informative videos, please like, share and subscribe to my channel CSC Core Concepts. Thank you.